In this lecture, we'll be studying about pumping lemma for context-free languages. So what is a pumping lemma for context-free languages? Pumping lemma for context-free language is used to prove that a language is not context-free. So if you remember, we have already studied about pumping lemma for regular languages, where we use the pumping lemma to prove that a given language is not regular. So if you have not watched that video and if you need to study about that, you can watch it in this playlist. And if you have already watched it and if you have already studied it, then this pumping lemma for context-free languages should not be a difficult topic for you, because the pumping lemma for context-free languages is almost similar with that of the pumping lemma for regular languages, but yes, there are a few differences. So we shall see what they are, and we shall see how we can use this pumping lemma to prove that a language is not context-free. Alright, so let's see how we can do it. If A is a context-free language, then A has a pumping length P such that any string S where the length of S is greater than or equal to P may be divided into 5 pieces S equal to U, V, X, Y, and Z, such that the following conditions must be true. So what we do is, let's say that we have a language called A. So we say that if A is a context-free language, then A will have a pumping length P. So we don't know what is the pumping length P, but it will have some pumping length such that any string S, so S is a string from this language A where the length of S is greater than or equal to the pumping length P, that string S can be divided into 5 pieces such that S equal to U, V, X, Y, and Z. So if you remember, when we studied for pumping lemma for regular languages, we divided the string into 3 pieces. But in this pumping lemma for context-free language, we will divide the string into 5 pieces, U, V, X, Y, and Z, such that the following conditions must be true. So if you divide it into 5 pieces like this, these 3 conditions must be true. And what are they? U, V raised to I, X, Y raised to I, Z is in A for every I greater than or equal to 0. So you have divided S into U, V, X, Y, and Z, and here if you raise V to the power of I and Y to the power of I, where I is greater than or equal to 0, then the string that you get even after doing this should also be in A. That means that string also should belong to the language A. And the second condition says that the length of V and Y should be greater than 0. And then the third condition says that the length of V, X, and Y should be less than or equal to P, which is our pumping length. So remember that these U, V, X, Y, Z, they are not strings, but they are the parts into which you have divided the string S. And after you divide this, these 3 conditions must be true. And if these 3 conditions are true, then we can say that it is a context-free language. So we are going to prove that a language is not context-free using this pumping lemma. So this is the conditions that we know, and let's see how we can prove it using pumping lemma. So in order to prove that a language is not context-free using pumping lemma for context-free languages, we have to follow the steps that are given below. So just as we did in the case of pumping lemma for regular languages, even in this case we will prove it using contradiction. Alright, so here we have the 3 conditions given and we already defined them. And now, since we are going to prove it using contradiction, what we will do is we will assume that A is context-free. So we have a language that we call A, and we will assume that it is context-free for the beginning. So we have already read that if a language is context-free, then it has to have a pumping length, and let's call it P. So as we assumed A is context-free, so it should have a pumping length, which we will call P. And then all the strings longer than P can be pumped. So any string whose length is greater than or equal to P can be pumped. That's what we read above. Now what we will do is we will find the string S in A such that the length of S is greater than or equal to P. So we have our language A, and from this language A we will take a string which we will call S such that the length of this string s should be greater than or equal to p, which is our pumping length. Now after you take that string s, we will divide that s into 5 parts: u, v, x, y and z. So we have a string and it is divided into 5 parts now. Now we will show that u, v raised to I, x, y raised to I, z does not belong to a for some value of I. So you have divided this s into these many parts. So when it is divided in this way, it is lying in this language a. We know that. Now we will show that this string s, which you have divided into these 5 parts, this part of v and this part of y, when you raise it to some power of I, that means if you repeat this v part and y part some I number of times, this new string that you obtain, you have to show that it does not belong to the language A. So we don't know what is the language right now, but when you have the example, you will know some rules that have to be followed for the language. So once you divide it in this way and raise it to these powers, you have to show that it does not belong to this language A. After that, consider the ways that S can be divided into u, v, x, y and z. So this string s, when you divide it into u, v, x, y and z, there are many ways in which you can divide it into these 5 parts. So consider all the ways in which you can divide the string s into these 5 parts, and after you find them out, show that none of these can satisfy all the 3 pumping conditions at the same time. So what are the 3 pumping conditions? These 3 conditions that we have read over here. So once you find all the ways in which s can be divided into these 5 parts, show that those divided parts cannot satisfy these 3 conditions of pumping lemma at the same time. So since it cannot satisfy all the 3 pumping conditions at the same time, s cannot be pumped, which is a contradiction to our assumption that A is a context-free language. If A is a context-free language, then it should be able to be pumped. But since we find that it cannot be pumped, we get a contradiction. Thus, we prove that A is not a context-free language. So these are the steps that you have to follow in order to prove that a given language is not context-free using the pumping lemma for context-free languages. So don't worry even if you feel a little bit confused seeing all these rules and steps. In the next lecture, we will be taking an example in which we will clearly see how to perform these steps in order to prove that a given language is not context-free using the pumping lemma for context-free languages. So thank you for watching this and see you in the next lecture with an example which will clarify this further.